the video for advanced algebra, topic 3, section 3, transforming linear functions. Transformation is just taking the graph and moving it up, down, left, right, making it steeper, have a steeper slope, make it have a flatter slope, just everything along those lines is a transformation. A translation is a type of transformation that shifts each point on the graph. The translation can be horizontal or vertical. When we do these translations or transforming linear functions, we talk about a parent function, and the parent function is f of x equals x. If I graph that, the y-intercept is 0, the slope is 1, so up 1 over 1, up 1 over 1, or down 1 over 1, however you want to go, it is this line. Okay, so if I do f of x equals, or let's change it to g of x. G of x equals x plus 3. What that does is it takes this parent function and it moves it up 3. So I go up 1, 2, 3, and I'll have these points. And that's a translation of the graph, a transformation. And there's millions of ways we can move these lines. If we look at the next graph, I have f of x equals 2x. For this one, that's the parent function. So I graph, the y-intercept is at 0, 0, the y-intercept's at the origin, but the slope this time is 2. So up 2 over 1, up 2 over 1, or down 2 to the left 1, down 2 to the left 1. And notice that the 2 made the graph steeper. Okay, putting a fraction in there would have made it flatter. Think if the slope was 1/4, I would have risen 1 and run 4. So it would have been a much flatter line. Okay. So what this first one does is it takes that graph and it moves it down 4. So all I have to do is take each point, 1, 2, 3, 4, and move it down 4. 1, 2, 3, 4. 1, 2, 3, 4. And draw the line. Okay. Then if I look at the next graph, it's going to move it down 4, but this plus 5 is going to move it to the left 5. So I take the opposite of what's in the parentheses, and that's going to move the x value right or left. Okay. And then I take the same as what's out here, and that's going to move that function up or down. So now I just need to take each point and go to the left, 1, 2, 3, 4, 5, 1, 2, 3, and down 4. So then take this point and go 1, 2, 3, 4, 5, 1, 2, 3, 4. And then take this point, 1, 2, 3, 4, 5, 1, 2, 3, 4, and keep going. And I can draw in that line. So that's what we're looking at today. And with linear equations, it actually isn't that difficult. Bottom is line. We want you to get the right answer. So if you want to take this equation and simplify it and graph it that way, I don't have a problem with that. Okay. So we want to look at the graphs of f of x equals fx plus 1, g of x equals 4 times the quantity x plus 1, and so what these do, we know that this takes the parent function and moves it up 1. And the parent function for this would be, f of x equals x. This takes the parent function and goes left 1, but it also changes the slope. And it's going to make the slope steeper. If you think about it, rise 4, run 1, rise 4, run 1, that's going to be steeper. And then this is going to take the function, it's going to move it to the left 1, and then take the slope, and it's going to make it flatter. Okay. So then, rather than doing the transformations, they wanted us to plot points so that we can see. So we can do that. If I plug -3 in here, I get -2. Plug in -2. Plug in -1. Plug in 0, 1, 2. And we can plot those points. -3, -2. -2, -1, -1, 0, 0, 1, 1, 2, 2, 3. And that is that first line. The second line, so take -3 plus 1, get -2, multiply it by 4, get -8. Take -2 plus 1, get -1 times 4 is -4. -1 plus 1 is 0, times 4 is 0. 1 plus 1 is 2, times 4, 0 plus 1 is 1, times 4 is 4, and then 1 plus 1 is 2, times 4 is 8, and 2 plus 1 is 3, times 4 is 12. Obviously, some of these points are not going to fit on my graph. -2, -4 does. -1, 0 does. Where am I? 0, 4. Does. What's my point at -1? Okay. So this point, this point, this point is what I've got on there. Missed that a little bit. So this took the previous line and it changed the slope. It made the slope go from here to being steeper up here. And then this next one is going to do the same thing. It is going to change the slope. And so if I plug in -3, get -2, you get -1/2. If I plug in -2, I get -1 in there, you get -1/4. If I plug in -1, I get 0. If I plug in 0, I get 1/4. If I plug in 1, I get 1/2. Plug in 2, I get 3/4. So not the nicest numbers to graph, but you can make that work. So -3, 1, 2, 3, -1/2. -2, -1/4. -1, 0. 0, 1/4. 1, 1/2. And 2, 3/4. So basically, we're looking at, in that line, this line, the one I just drew, this one right here, is flatter than the original. And so what we want to see is that when we change the slope, we're actually looking at a vertical stretch or compression. So it changes the graph vertically. We say vertical stretch or compression. If k is greater than 1, if the slope is greater than 1, then the transformation is a vertical stretch. It's going to make it steeper. Okay, and if k is less than 1, it's a vertical compression. It's going to make the graph flatter. And just, common sense wise, if I ask you to graph f of x equals 75x, we're going to rise 75 and run 1. It's going to be a pretty steep graph. But if I ask you to graph f of x equals 1/75x, the slope is 1/75, you're going to rise 1 and run 75. That's a pretty shallow, flat graph. In fact, it's almost 0, right? So, if as the slope gets bigger and bigger and bigger and bigger, that graph gets steeper and steeper and steeper and steeper. And as that slope gets closer and closer to 0, but not a negative number, it just gets closer and closer to 0 and is less than 1, it's a fraction, then the flatter that graph is going to be. And then we want to look at the same thing, what happens horizontally. So again, we start out with x plus 1, y equals x plus 1, or f of x equals x plus 1. And we plug in -6, we get -5, -2, 1, 3 plus 1 is 4, 6 plus 1 is 7. So -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. And then -3, -2, 0, 1, 3, 4, and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And there's that first line. Okay. Now we plug in, let's see, that's going to be -18 plus 1. That's obviously not going to fit on our graph. -9 plus 1 would be -8. 0 plus 1 is 1. 9 plus 1 is 10. And 18 plus 1 is 19. Not a whole lot of this is going to fit on our graph. Notice that for each one of these graphs, even the vertical one that we looked at before, that point 0, 1 stays the same. It's like that's the point we're spinning off of. So let's see, -6, -17 is going to be way down here somewhere. -3, 1, 2, 3, 4, 5, 6, 7, 8, right about there. and then 0, 1 as we said, then 3, 4, 5, 6, 7, 8, 9 up here somewhere. Okay. Just going to add another couple points here to help, just using slope. So there's that graph. And then here, let's see, 1/3 times -6 would be -2 plus 1. If I plug in -3, I get -1 plus 1. If I plug in 0, if I plug in 3, if I plug in 6. So -6, -1, -3, 0, 0, 1, 3, 2, and 4, 5, 6, 3. And there is that line. So this is f of x. This is g of x. This is h of x. And notice here, okay, this goes back to our vertical stretch and compression. This x-intercept stayed the same, and the graph rotated on that. For this horizontal stretch and compression, the y-intercept stayed the same, and the graph changed off of that. Okay, so again, if the number is getting bigger than 1, it's going to be a horizontal compression, and if the number's a fraction between 0 and 1, that's going to be a horizontal stretch. Okay.